All right, this is video one of topic 1.6, and we begin by revisiting something we discussed in class, that we know that sometimes limits do not exist, and they will not exist for three specific reasons. And so we're going to go through each case in video one here just to refresh our memory that there are three different ways that a limit will not exist. A limit will not exist if the limit of the function from the left side does not equal the limit of the function from the right side as x approaches c from the right. So this is basically saying if you remember this equation from one of the videos, one of the previous videos, let's call this f of x. F of x is equal to the absolute value of x over x. What did that look like? Do you remember? This is one of those graphs that you needed to just have in your brain here. So this was a graph that was down here at -1, but then up here at +1 for the right side of the y-axis. So this is a case where the left side and the right side do not match, right? They do not agree from the left and the right. So one of the ways that a limit does not exist is if the left-sided limit and the right-sided limit don't match. And an example of that would be this picture. This is the easiest jump discontinuity that we can see. Otherwise, we'd have to build the piecewise function and make it more complicated. This is one of the quickest way to do that. Okay, so what's another reason that a limit does not exist? Limit won't exist because of infinite behavior. Infinite behavior. And what I mean by that is if we draw a graph, maybe the graph does something like this. So if I were to take the limit as x approaches 0, right? If I take the limit as x approaches 0 of this graph, the limit doesn't exist because it goes to infinity. Now, I can write that the limit of this function, and we're going to call this function g of x. This is the equation for this function. G of x is 1 over x squared. So this is a squared rational function, and you'll notice that on each side of the y-axis it goes up. I could say that the limit of g of x as x approaches 0 is infinity, but that means that the limit doesn't exist because there's infinite behavior. So just because some people, and I will say, and we had a discussion in certain groups about this, the AP exam on a free response question will allow you to say that the limit, they would allow you to do this. The limit of this function g of x as x approaches 0 is positive infinity. But with the understanding that there isn't a limit because there isn't a specific finite y value that the graph is approaching. So some people, me, would write it like this because the limit doesn't exist. Why doesn't it exist? Oh, because there's infinite behavior. And then the third case we talked about was because of oscillation. And I want to show you a graph of a function that will definitely show us this around x equals 0. So I'm going to graph this function, and I think you can see it when I switch over to the calculator. Let's do it that way. So here's the function, sine of 1 over x. Now we are in radian mode because we'll be dealing only in radian mode for our derivatives and our behavior models for trigonometric functions. I'm going to do a zoom 6 to get a standard window. And, oh, I didn't turn it on. Nope, I didn't turn it on. Let's graph. So if you look at this, it seems like the limit would be 0, right, from both sides as I get closer and closer to 0. So we're specifically, I guess I should say, we're looking for this limit, the limit of h of x as x approaches 0. Just like over here, we were looking at the limit of f of x as x approaches 0. So my three examples that I'm using, I'm approaching 0. So going back to this last one, it looks like it's approaching 0, right? But look what happens as I zoom in. I'm going to zoom in around the origin. You can see the little blinking cursor at the origin. I press enter and I zoom in. And I see, oh, there's something weird. So I'm going to zoom in a little bit more. Whoa. And if you zoom in one more time, I think it'll allow you to do one more time. As I get closer and closer to the x value of 0, the graph does not settle in on a specific finite value. Instead, it just like oscillates back and forth and continues to do so as I get closer and closer to 0. So the graph of this, if we were to make a graph, will look something like, let's go back to the original picture. So we're coming in from the bottom, but then it does this, and we're coming in from the top, and then it does this. Like there's oscillation going on as I approach 0. Like it just goes back and forth, back and forth, back and forth. So there's never a y value on which it settles because it just oscillates back and forth. Three different cases why a limit will not exist. You have to be familiar with all three because you might run into a situation where they're going to either ask you, does the limit exist? Or you can figure out right away that it's not a possibility because of one of these three cases.